Welcome to the slideshow number 2 of Bio 196. This one deals about water and its life-giving properties. So water has 7 very important life-giving properties, and we will review the 7 of them a bit more in detail in the next slides. So the first main property of water is that all physical states of water exist in conditions seen on Earth. The second one is that it's an excellent solvent for polar substances. The third, it is that it drives the hydrophobic effect. The fourth is the cohesive effect, or the cohesion of water. The fifth is the fact that ice is less dense than liquid water. The sixth property is the high specific temperature. And the seventh property is that pure water is neutral and can form aqueous solutions that can be acidic or basic. So let's review these properties together. The first one, it is that all the physical states of water can be found on Earth, and this is very important for the recycling of water. All these forms have a very important part, or play a very important part in the recycling of water and in sustaining the life of many living organisms on Earth. So gaseous water is seen under the form of vapor. Liquid water is found a bit everywhere, and a lot of it is seen in living organisms. And solid water exists under the form of snow and ice. All these three states play very important functions for the living organisms that are present on Earth. The second property comes from the fact that water is polar, and it gives it its capacity to interact with other polar or charged substances. And this comes from the formation, the way water is formed. And you all know that water is made of one oxygen atom and 2 hydrogen atoms, and they are held together by the means of 2 polar covalent bonds. If you're not sure of what a polar covalent bond is, I invite you to watch the first slideshow about atoms and molecules. So water is formed by the chemical reaction between 2 molecules of hydrogen, or H2, and 1 molecule of oxygen, O2. And these 2 molecules will be dissociated so that the covalent bonds that are present between the 2 atoms will reorganize and form 2 new molecules with each 1 oxygen and 2 hydrogen atom. The very strong electronegativity of oxygen compared to hydrogen will make it so that the covalent bond that is formed between oxygen and hydrogen will be polar. It means that there is an unequal sharing of the pair of electrons, and this will make the molecule with 2 sides, or a polarity, so one end that is slightly positively charged and one end that is slightly negatively charged. So it gives it its capacity to interact very easily with polar or charged substances and easily dissolve them. We call these substances hydrophilic because they have a tendency to interact with water. So in other words, it says that they are water-loving substances. In contrast, because they cannot interact with substances that are non-polar, because water is itself polar, so it has a charge, it tends to interact with other molecules that have a charge, even if it is partial. So molecules that don't have a charge are said to be non-polar, and they tend to not interact with water and to, in contrast, cluster together. This is the hydrophobic effect. So this is a second derivative property of water and of its polarity. I invite you to watch the small animation that shows the formation of water molecules, so you can see the polarity of the molecule. Then, talking about soluble substances, or the fact that water is an excellent solvent for polar or charged molecules. What is exactly an aqueous solution? It is, in fact, the presence of molecules dispersed in water, and when they are dispersed in water, they interact very closely with water, so closely that in fact water can interact directly with the charged primary elements. So in the example given here on this picture, you have a salt of sodium chloride, and you see that when it is dissolved in water, there is an interaction between the positively charged sodium by the mean of the oxygen atom of water, which is negatively charged, and in contrast, the chloride ion that is negatively charged will interact with all the positive charges of the hydrogen atoms of water. So water will create a hydration sphere around all these elements, so the individual sodium and chloride ions, so that the salt itself will be totally dispersed in water in the form of individual elements surrounded by a hydration sphere. So the water is the solvent, the solute is the molecule that is dispersed in the water, so here the chlorine ion or the sodium ion, and the whole thing is called an aqueous solution. That being said, I want you to also understand that we may sometimes speak about a soluble molecule like a soluble protein or a soluble nucleic acid, and this when we say that, it doesn't mean that the protein or the nucleic acid is totally cut into pieces and dispersed in the water. It means that the whole molecule has slight charges that may be positive or negative, and that water molecules will interact very closely with all the amino acids or all the elements that are present at the surface of the molecule itself. So here on this picture is shown a protein that is a soluble protein, and you see that you have water molecules interacting with the protein a bit everywhere, probably at all the locations where there is a slight positive or a slight negative charge, but it won't destroy and chop the protein into little pieces. It will simply make a hydration sphere around the protein. The next property is a property of cohesion, and it comes from the presence of hydrogen bonds between water molecules, and the fact that these hydrogen bonds will stick water molecules together. So the first thing that is very important for living organisms is that it gives water a certain level of tension at its surface that allows some animals or insects or even plants to stay at the surface of water without drowning. Okay, so here is shown a little insect. It also, the same property, the cohesion property, will be the property that makes water go up when it is in a specific condition. So for example here you have this effect, the effect of capillarity, the fact that molecules of water stick together will drive water up. So here when a piece of sugar is put in contact with water, so here it is coffee, but coffee is simply water in which you have coffee particles solubilized. So you see that the water will start at the bottom of the sugar piece, but it will quickly go up, and the molecules that are the most upwards will drive the other molecules up because they are sticky with them. A bit more important, this property will be at the origin of the circulation of water or sap in the vessels of plants. So water is present in the ground, and it has to go up to the last top cells of the plant, and the way it does that is by the fact that water molecules are cohesive and they can go up into the tiny tubes. So basically what happens is that when the molecule at the top evaporates, then it will drive the whole column of water molecules up, and the circulation can go on. Okay, and water molecules are taken from the bottom and driven up to the top like that by the means of the cohesive property of water molecules. Then density of water. You remember that we say that there are lots of hydrogen bonds between the hydrogen atoms of one water molecule and the oxygen atom of another water molecule. And when you're at a temperature that is higher than 0 Celsius degrees, then what will happen is that water is liquid. So hydrogen bonds constantly form and dissolve. Water molecules can go closer or further away. The space between two molecules will be very variable, and water is in constant motion. So this is why the bonds form and deform constantly. Now, when the temperature decreases, and especially when it decreases below 0 Celsius degrees, what will happen is that the hydrogen bonds will become stabilized, and there will be the formation of bonds between all the water molecules. So one water molecule can possibly make 4 bonds, 2 by the mean of its hydrogen atoms and 2 by the mean of its oxygen atom. And by doing so, each water molecule will be surrounded by 4 other water molecules, and the space between each of them, or the length of each hydrogen atom, will remain constant. This will create a structure that is much less packed than the liquid water, where the space between molecules can vary all the time. So the fact that it is less packed makes it less dense, and therefore ice will always float on water, and this will give very important properties to water, especially fresh waters or even seas, because all the animals that live in liquid water will be able to survive below the layer of ice that can form when the temperature decreases. Then the layer of ice that is found on the top will isolate the liquid water that is at the bottom, and all the living organisms that are here will be able to survive. The next property is the high specific temperature. So first we need to define what a specific temperature is. In fact, it is the amount of energy that is required to raise the temperature by 1 Celsius degree. So in the case of water, this energy corresponds to 1 calorie. You know that molecules are in constant motion, and because water has hydrogen bonds constantly forming and resolving, the motion of water molecule is kind of restricted by the fact that you have hydrogen bonds sticking them together. But when the temperature raises, you have less and less hydrogen bonds that are formed, and in fact, when you raise the temperature, it will break the hydrogen bonds, but you need to break the bond before you have more motion between the molecules. And the temperature increase will be seen only when the temperature will increase their motion, so after you have broken the hydrogen bonds. So from the small level of motion, you will raise to a higher level of motion, but only after the hydrogen bonds have been broken, and this will create a kind of delay between the amount of energy that is input in the solution and the fact that the temperature increases. So this will overall minimize the changes in temperature in the external and internal environment of all the living organisms. And when we say the internal environment, we have to remember that in all cells, all the chemical reactions that occur at a time create an increase or a release of energy under the form of heat, and this heat has to be dispersed. The fact that water can tolerate changes in temperature like that makes it possible for cells to regulate much more efficiently their temperature. So if we see the specific heat of several substances, you see that water has a very high specific heat, a specific temperature. So you need to have 1 calorie of energy in order to raise the temperature by 1 Celsius degree, while for other substances, like for example glass, you need just 0.2 calories to raise the temperature of glass by 1 Celsius degree. So water is much more resistant to heating because of the need of breaking hydrogen bonds before the molecules can have a greater level of motion. Note the fact that ice has a lower specific heat compared to liquid water, and I want you to think about that and try to find an explanation to that. Now the last property is that pure water is neutral. First, it is important to understand that water under the form H2O, so 1 oxygen bound to 2 hydrogen atoms, can sometimes dissociate into 1 hydrogen atom and 1 oxygen and another hydrogen atom on the other hand. So what happens also at this time is that the hydroxide ion, the OH ion, will keep the electron of the hydrogen atom. So the hydrogen atom will now be called a proton because it has lost its only electron, and the OH ion will be negatively charged because the electron has stayed there. And in most of the cells, the concentration of protons and the concentration of hydroxide ions is the same. So we have overall a pH of 7. So it means that in most cells, the solution or the water that is there is neutral. Okay, so the amount of protons is the same that the amount of hydroxide ion. Now, sometimes water can have substances that are dissolved in a solution, and water can exchange protons with these substances. So it is the fact, for example, with vinegar. So if you see here acetic acid, which is the substance that is acidic in vinegar, when it is put in presence of water, water will be able to catch 1 hydrogen atom without its electron, so the electron will stay with the acetate, and in contrast the proton will go with the water and it will create the acidic substance. So when the amount of protons is higher than the amount of hydroxide ions, or the concentration of proton is higher than the concentration of hydroxide ion, then the pH of the solution is below 7 up to a minimum of 0, and this solution is said acidic. In contrast, if you have a lower concentration of protons compared to the concentration of hydroxide ion, then the pH is above 7 with a maximum at 14, and this is a basic solution. So here are indicated a couple of different solutions where you see that the distilled water is at 7 or neutral, but all the solutions made with water but containing various substances, like for example milk of magnesium or urine or black coffee, can have various levels of acidity because of the property of water that is able to catch protons from other substances or to release protons when in presence of certain substances. So this was the last property of water, and this explains to you why water is so important to sustain life. And it is not impossible that other molecules can do the same thing as water and have the same properties, but on Earth, only water is known to have all these properties that are absolutely necessary for life of organisms under the condition of pressure and temperature that we know here.